The history of mathematics. Now, I'm sure at some point there was one group or civilization that went, I want that many sheep, or whatever the hot commodity was at the time. However, there is no way of knowing exactly who or when that was. We do know, however, that making that connection, assigning symbols and words to specific number quantities, is profound. It changed everything about the way we live, even to this day. We communicate with each other constantly. Computer codes and algorithms are needed for our connection with others online. Number systems help us to understand and converse efficiently. There are many, many ways mathematics and applications in our day-to-day lives affect us. Now, early mathematics kind of rests in these areas. Mesopotamia did some pretty intricate things. For example, they figured out the Pythagorean theorem long before Pythagoras even came into the picture. China used something similar to our present-day decimal and fraction systems in their civilization, and India created numeral systems and did a lot with arithmetic and other calculated mathematics. The main thing to take away from this era of math is that there at no point were formal proofs brought into the equation. They didn't do anything with trying to prove this is why this works. They just kind of figured it out, decided it was good, and moved on from there. The proofs came along in a different era of mathematics, Greece. Now, the basic idea of proofs, you prove things by taking things already proven and going from there, was invented by the Greeks. Now, according to Stanford University, they mostly use geometry. If we take a moment to pause for a reference point, everything you've learned up until now, including everything you will learn until non-Euclidean geometry, most of us won't get there anyway, all of that the Greeks knew 2,500 years ago. Trigonometry was actually started by astronomers, and it was an extension of geometry. It was essentially used as a way to figure out how the Earth moved around the sun. Now, some important Greek mathematicians, we have Pythagoras, and there's no way of knowing whether or not he actually proved the Pythagorean theorem. It's possible that he did, but more than likely, it was one of his students in the school he founded of philosophy that actually proved it. Either way, the theorem is named after him, so clearly he did something right. A quick side note, this school of philosophy is also the first institute to ever introduce the theory of irrational numbers. Next we have Euclid. He has a text called Elements, and according to many influential math professors, this text is the most important text written on the subject of math ever. And it's been in print for 2,400 years. For reference, Lincoln studied Euclid. Newton studied Euclid. People would quote him similarly to how you would quote the Bible in a social setting. That's how influential he was. Now, Archimedes was also an extremely influential mathematician. He was 2,000 years ahead of his time, not only with geometry and number theory, but concepts in calculus as well. He was one of the brightest mathematicians to have ever lived. Now, while the Greeks are killing the game, over in Europe, not much is happening. Approximately 0 things happened in Europe mathematically from 400 to 1200 AD. That's an exact calculation for you. But however, in the Middle East, there was a lot of learning for the sake of knowledge. Islam was founded in the 7th century, and they were really working to broaden their horizons. Algebra comes from the Middle East during this time period, and the word itself actually stems from a text written there as well, entitled The Condensed Book on Calculations of Algebra. As you can see, very similar words. They also created Hindu-Arabic numerals that we still use to this day, 1, 2, 3, 4, etc. It originally stems from India, and it was kind of adapted by the Middle East during this time as well. This numerical system made its way to Europe eventually, don't worry. The Fibonacci sequence, which we all know, 1, 1, 2, etc., was created by Fibonacci in 1228 in Italy. But Fibonacci should probably be commended just as much for his work in really pushing the Hindu-Arabic numeral system in Europe during this time. It took about 300 years for the number system to be in a widespread use around the world, but it is the most used numerical system to this day. To speed through a little bit of mathematical milestones, for a very, very, very long time, through about the 17th century, we were using a base 60 decimal system. We still do for things like latitude and longitude. Simon Stevin came along and advocated for a base 10 decimal system in his literature, The Art of Tenths, which was published in 1585. It wasn't really until 1624, however, when the base 10 numeral system really blew up. John Napier, a Scottish mathematician, started dealing with logarithms in 1614, while trying to transform multiplication into addition. He looked at trig identities to do so, but he used what was theoretically a base 1 over e, as you can see here. Keep in mind that e had not been invented, discovered, it's not even in the picture at this time, so clearly that was a very difficult way to go about it. Next, Henry Briggs came along, and he actually met Napier, and decided that a base 10 would be a much better base to work with. According to the Encyclopedia Britannica, base 10 logs are actually referred to as Briggsian logarithms because of him. It was at this point when decimal numbers kind of came more into play. There was now a need for them. Next on the docket, of course, is calculus. From about 1600 to 1660, that's really when calculus came to thrive. It was a big time for mathematicians. Now, just to be clear, what we use today in a high school setting, for example, what many of us are in right now, is the calculus. The calculus is a set of rules and ways to manipulate and work with numbers. Calculus, on the other hand, is what geniuses do. It is what advances mathematics. It's what these folks were doing at that time. They were figuring out and doing calculus. The calculus comes later. Now, Barrow worked at Cambridge University during this time, and during one of his lessons, he explained the geometrical connection between integrals and derivatives. Then he moved on. The calculus aspect of it was left to one of his students, Isaac Newton. Most of Newton's work was conducted from 1665 to 67, and almost none of it was published during his lifetime. In 1687, however, he did publish his book, The Mathematical Principles of Natural Philosophy, which is the most influential book in the history of science. It is no doubt that he is a genius, but his notation for math was horrific, and he didn't publish much more than that. I would not say that he is one of the best mathematicians in the world, but he is definitely one of the most prolific physicists in the world. His genius lies in this publishing. He showed that if you want to understand the world, here's how you can figure it out. More like an instruction book for science. Now, Leibniz's calculus is what we use today. It was developed a few years later, around 1675. He was the calculus guy. He developed an abundant amount of math, and he did so with the purpose of sharing it. He wrote extensive notes and journals on the subject for the purpose of publishing. We use Leibniz's notation today. The integral symbol, that's all him. Now, here's a quote from the Oregon State University. He, Leibniz, produced the first binary logical number system, invented calculating machines, stated the physical law of conservation, among other things. His work is recognized as contributing immensely to the modern computer. Now, the 18th century brought on physics, engineering, and other applications of calculus. A lot of advancements occurred here. L'Hopital did his work during this time along with Euler. Now, Leonhard Euler was a big dog during the 18th century in math, and he is truly a prolific figure in mathematics in general. Now, if we move on to the 19th century, this is where Euclid's geometry, if we remember him from ancient Greece back in the day, started to be questioned. This marked the start of mathematicians attempting to break the rules of math put in place by their predecessors. Now, some big names during this time, both German, mind you. We have Carl F. Gauss, who is a big name in math as well, And we also have Bernard Riemann. Now, he did elliptical geometry in 1854, and a lot of us also probably remember him from Riemann's sums. Now, by the 1900s, the arithmetization of mathematics was basically in place. Here's where people started to take those arithmetizations and run. Everything prior to 1900 that I've talked about so far is obviously a lot of math. However, more math has been developed in the past 100 years than the 2,000 years before that. One of the most prolific mathematicians during this time was Alan Turing. He was a British mathematician who worked to break the Enigma code during World War II. His other work also gave way to modern computer science, and he contributed enormously to our understanding of mathematics. He really worked on developing the first codes for artificial intelligence as well. Now, mathematics, like everything else in the world, is constantly evolving. And no matter how hard you try to argue against it, there is no doubt that it plays a role in every step of our lives. Whether it's something as big as the current work and actions being taken to flatten the curve of COVID-19, or something as small as children arguing how many M&Ms they're willing to trade for a candy bar, it molds our world. Communication does not rest only in spoken and written words. The development of Hindu-Arabic numerals and this system gave us ways to have conversations about the stock market, how many goals our favorite player scored last night, or how many questions we got right on a test. The history of mathematics goes hand in hand with our ability to communicate. And as math develops more and more, that ability will too.